Something from another star just passed through our solar system. It carried water from a world we have never seen. It triggered the most sensitive alien signal search in history, and the scientists studying it say the ingredients it brought with it are the same ingredients that life on Earth is built from. This is not science fiction. This is what has been happening in our own solar system over the past 12 months, and most people on Earth missed almost every single extraordinary moment of it. The object's name is 3I Atlas. It was first spotted on July 1st, 2025, by the NASA-funded Atlas Survey Telescope located in Rio Hurtado, Chile. The moment astronomers calculated its trajectory, its speed, and the direction it came from, they knew immediately that they were looking at something extraordinary. The object had arrived from the direction of the constellation Sagittarius, at the heart of the Milky Way galaxy. Its speed and path through the solar system were completely inconsistent with any object that could have originated within our own Sun's gravitational family. It was moving far too fast. Its orbit was hyperbolic, meaning it was not bound to the Sun by gravity and would pass through our solar system once and then continue outward into interstellar space forever. 3I Atlas had been traveling through the void between stars, possibly for millions of years, before its path happened to carry it through the tiny cosmic neighborhood where we live. It was only the third confirmed interstellar object ever detected passing through our solar system in recorded human history. The first was Oumuamua, discovered in 2017, a strange cigar-shaped object that sparked enormous controversy because its behavior was unusual, and one Harvard astronomer controversially suggested it might be an artificial probe. The second was 2I Borisov, discovered in 2019, a relatively faint comet that confirmed interstellar objects were real visitors and not a fluke. But 3I Atlas was different from both of its predecessors in ways that made scientists stop and pay close attention. It was the brightest of the three, it was the fastest, and it came from a completely different direction than the previous two objects, approaching from toward the galactic center rather than from the outer galaxy. Astronomers estimated its diameter at over a kilometer wide, possibly as large as 20 kilometers, depending on the calculations. And when they turned their instruments toward it, what they found inside it changed the conversation entirely. NASA's Neil Gehrels Swift Observatory was one of the first major space telescopes trained on 3I Atlas after its discovery. Swift operates in ultraviolet wavelengths that ground-based telescopes cannot observe because Earth's atmosphere blocks that part of the spectrum. When the Swift team turned the telescope toward the interstellar visitor in July and August of 2025, they detected something that no astronomer had ever seen from an interstellar object before. Hydroxyl gas, the chemical fingerprint of water, was glowing faintly in ultraviolet light around the comet's nucleus. 3I Atlas was releasing water. Not just a little water. It was losing water at a rate of approximately 40 kilograms per second, a stream of ice turning directly into vapor even at a distance nearly 3 times farther from the Sun than Earth. Most comets from our own solar system remain completely inactive at that distance, frozen solid by the cold of the outer solar system. 3I, our Atlas, was already active, already outgassing, already broadcasting a chemical message from whatever planetary system it came from. Dennis Bodowitz, a physics professor at Auburn University who studies cometary chemistry, described what the water detection means in a way that captured the full significance of the discovery. He said that when scientists detect water from an interstellar comet, they are reading a note from another planetary system. He said it tells us that the ingredients for life's chemistry are not unique to our own solar system. Think about what that means. An object formed billions of years ago around a star we have never identified, in a planetary system we have never observed, carries within it the same fundamental chemical building blocks that produced life on Earth. Water is not just important to life, it is essential to it. Every living cell on Earth requires it. Every biochemical process and every organism that has ever existed on this planet depends on it. And here was a visitor from another star, carrying water across light years of interstellar space and releasing it in our neighborhood for the first time in the 4.6 billion year history of our solar system. The James Webb Space Telescope also trained its instruments on 3I Atlas. Researchers from Caltech used JWST's MIRI instrument, which detects mid-infrared wavelengths, to examine the comet's chemical composition as it approached the Sun in late 2025. What the spectra revealed was a detailed inventory of what this other planetary system is made of. JWST detected water, carbon dioxide, methane, and nickel fluorescence in the comet's coma, the cloud of gas and dust surrounding its nucleus. The methane detection was particularly striking, as 3I Atlas rounded the Sun and began heading back out of the solar system. In late 2025, the methane emissions increased dramatically, a sign that the heat of its closest solar approach, called perihelion, was exposing interior layers of the comet that had been shielded from radiation for millions or billions of years. Those inner ices, formed in a far colder environment than our own solar system, were being exposed to sunlight for the first time in their existence and vaporizing in a chemical release that JWST captured in extraordinary detail. On October 30th, 2025, 3I Atlas reached perihelion, its closest approach to the Sun, coming within 1.4 astronomical units, just inside the orbit of Mars. Days before perihelion, astronomers at the South African Radio Astronomy Observatory pointed the Meerkat radio telescope at the comet. 2 previous attempts to detect radio signals had produced nothing. But on October 24th, the third attempt succeeded. The team detected radio absorption lines from hydroxyl radicals, again confirming the presence of water breaking down under sunlight in the comet's surrounding cloud. Meerkat, one of the most sensitive radio telescope arrays in the world, had picked up a genuine interstellar signal, a chemical fingerprint broadcast by a visitor from another star. And then the question that was always hovering in the background became explicit and official. Could it be artificial? Could 3I Atlas be more than a comet? The Breakthrough Listen program, the most well-funded SETI search in history, turned its resources toward the object. The 100-meter Greenbank telescope in West Virginia was directed at 3I Atlas on December 18, 2025, the day before the object's closest approach to Earth. The search was conducted across 4 different radio frequency bands covering 1 to 12 gigahertz. Scientists analyzed over 471,000 candidate signals. After applying sky localization filters and eliminating known radio frequency interference sources, 9 events remained for detailed examination. Every single one of them turned out to be caused by human-made radio interference from Earth. No candidate techno-signature was found, no narrowband transmission, no repeating pattern, no signal that could not be explained by natural chemistry or terrestrial contamination. The most sensitive alien signal search ever conducted on an interstellar object produced a clear, definitive, and honest answer. Nothing artificial was detected. Avi Loeb, the Harvard astronomer who had argued most publicly that Oumuamua might be an artificial probe, and who followed 3I Atlas with intense interest, noted that NASA's Juno spacecraft was positioned to listen for any radio signals as the comet passed within 53 million kilometers of Jupiter in March 2026. Juno used its dipole antenna to search for signals at low frequencies from 50 Hz to 40 MHz. Again, nothing artificial was found. The scientific consensus, stated plainly, is that 3I Atlas is a natural object. It is a comet, formed in another planetary system, carrying that system's chemistry across the galaxy on a journey that has been underway for millions of years. It is not a probe. It is not a signal. It is something arguably more profound. It is a physical sample of another star's world, arriving in ours uninvited and unrepeatable. ESA's JUICE spacecraft, currently en route to Jupiter to study its icy moons, briefly turned its navigation camera toward 3I Atlas in November 2025 as the comet passed by. The images captured by JUICE showed the comet's coma clearly against the darkness of space. The data was downlinked to Earth in 2 marathon 11-hour sessions on February 17th and 20th, 2026, through ESA's Deep Space Antenna Network. Engineers who worked through the night to squeeze every possible bit of data from that brief encounter were clear about what motivated them. They had a once-in-a-civilization opportunity to observe an object that had come from another star. It was not going to come around again. ALMA, the Atacama Large Millimeter Array in Chile, added its own finding to the growing portrait of 3I Atlas's origins. The ALMA data suggested that the comet formed in a far colder environment than our own outer solar system, implying it originated in the deep outer regions of another planetary system, perhaps a region analogous to our own Oort cloud, but belonging to a star that has never been identified and may never be. The chemical ratios of its ices, different from those found in solar system comets, carry a record of the temperature, radiation environment, and chemistry of that foreign planetary system, encoded in frozen form, preserved for millions of years in the cold of interstellar space, and now read by our instruments for the first time. What makes the 3I Atlas story so significant is how it changes the way scientists think about the exchange of material between star systems. For most of the history of planetary science, each solar system was thought of as a closed system, an island of rock and ice orbiting a star, isolated from all others by the emptiness of interstellar space. The discovery of 3I Atlas and the detection of water within it has accelerated that challenge into something close to a paradigm shift. Solar systems are not isolated. They shed material continuously. Comets and asteroids get ejected by gravitational interactions with giant planets and drift outward into interstellar space, where they travel for millions or billions of years until encountering another star system. Our own solar system has certainly ejected material the same way. Some fragment of our solar system's history may be drifting through another star's neighborhood right now, carrying information about our chemistry and composition. The universe is engaged in a slow, patient exchange of matter between stars, and 3YS Atlas is the most legible letter in that exchange that we have ever intercepted. By April 2026, 3YS Atlas had passed the orbit of Jupiter on its outbound journey and will not leave the solar system entirely until approximately 2029. The window for useful scientific observation is narrowing as it grows dimmer and more distant each month. What scientists have learned from it will shape the field of interstellar science for decades. Teams from NASA, ESA, Auburn University, Caltech, and Breakthrough Listen have all published findings, each adding a layer to the portrait of this object and the distant planetary system it came from. And the possibility that the next interstellar visitor could arrive before 3I Atlas has even left keeps astronomers watching survey telescopes with an attentiveness that was unimaginable before July 1st, 2025. Meanwhile, at the true edge of our solar system, a completely different kind of interstellar milestone is approaching. On approximately November 13th, 2026, Voyager 1 will be one full light day from Earth. That means the radio signal it transmits continuously, traveling at the speed of light, the fastest speed the universe permits anything to travel, will take exactly 24 hours to reach the antennas of NASA's Deep Space Network back on Earth. Every piece of data it sends about the true interstellar medium, the plasma density, the magnetic field directions, the radiation environment between the stars, takes a full day to arrive. Voyager 1 is not a relic. It is an active scientific instrument at the edge of what human civilization has ever reached, sending back data from a place that 3I Atlas traveled through for millions of years on its way here. These two stories, the interstellar comet that arrived in our solar system carrying water from another world, and the spacecraft we built in 1977 that is now crossing the threshold of one full light day from home, together tell a single and deeply important story about where humanity stands in relation to the universe at this moment in history. We are close enough to interstellar space to receive physical visitors from it, rock and ice from another star's planetary system, carrying chemistry that tells us the ingredients of life are not unique to our neighborhood. We are far enough into that same interstellar territory to have sent one of our own objects into it. A probe launched nearly 50 years ago that is still transmitting, still alive, still sending back data from a region of space that no telescope can reach, and no human will visit in any of our lifetimes. We can detect the chemistry of other planetary systems arriving in our neighborhood and read it like a message from an unknown sender. We can hear the whisper of our own probe from the void that those visiting objects cross to reach us. We cannot yet reply across the full distance. We cannot yet follow. We cannot yet know whether the star that created 3I Atlas harbors planets with life, or whether the universe is full of chemistry like ours but empty of minds like ours. But we are asking those questions more precisely than any generation before us. We are listening with instruments sensitive enough to detect a signal from another star system if one exists. We are building the telescopes, the probes, and the understanding that will eventually let us look farther and know more. And the edge of our solar system, which once seemed like the boundary of the knowable, the universe, turns out to be just the beginning of a story that our species is only now learning how to read.